So welcome everybody to this very short episode. I promise to do some, like some things around DSA, um, especially around linked list that we, like recently talked about, right? So I'm just gonna share my screen and I'll just try to explain, and then we'll just try to like recreate the whole thing right from scratch. So this is a repo that we've been like using. So you can get access to this repository, right? If you go to JavaScript, think JavaScript hyphen algorithms by Tracklab, and you would have access to all of this here. So I'm just going to quickly run to the repository, GitHub, and then you can do JavaScript algorithms, right? And then you have access to, yeah, that's the repository here. So I try to keep a fork of it so that I can also be able to like use anytime I need to use it. But it's a very powerful, very powerful repository. It has a lot of stuff. So I'm just going to go into the data structure folder, and then we can see the linked list. So the linked list has two major things. We'll also look at the test also to get to understand like how to write tests and how to like solve problems with linked list. But the major repository here is what the node, right? So a node is just an object that has two things inside, which is what value and next. And it also exposes a toString method that you can give a callback, right? That is, you can give it a function, and then it can try to either use the callback, right, or it will just exactly just give you whatever the current value of the linked list is. Again, this whole structure here can be implemented with functions, but definitely I'm going to try to just quickly run some things here, just the same thing, right? Just trying to, I'm running this with Coca, right? And Coca is able to run all of this for me, but I'll also show you how to run it without Coca, right? So here, if you can hear me very, very well, I believe that for the one we just saw earlier, right, we can have a function, and the function is called node, and the function accepts two things. It's supposed to accept something we call value and something we call what next, if possible, right? And Copilot already knows what we want, right? So this is the function here, and we can also say that this function has like node. It's a constructor function. It has a toString operation, and here it can accept a callback, right? A CB. I could just call it a CB, just short. And the goal of the CB is to, in case we want to maybe pass a special thing to the toString method. So how do you initiate? How do you create this node now? The way to create this node is like you have what node equals to what new node, right? New node, and so the first node here is what we can pass 1. Now the situation here is that if I pass only 1 here, there's going to be a problem here to this code base. So if I console.log what console.log node, let's see, let's just do a start here, start on current as well here. So if I try to so here you just have an object that has value, but now look at next here. Next is undefined, right? So it's not so the idea is that because we have next here and we're not passing it any value, so we can use like default here and set a default to be null, so that anytime somebody tries to create a node without creating a next, then by default the next will be what? Null. So if we want to create another node now, which is going to be the next one, then we can say, well, new node, right? and then you pass this what 2, and we close it here, and that should be a full what that should be. So automatically you can see the log here. We have what the current value is 1 and the next node is 2, right? And when you look at the next, that next, it's a node and it has its own value, and it has another next, which is what null. So I mean, you can keep just nexting it like that, and if we create another new node here, I mean, it's the cycle continues. And this is what you have with linked list. That is, the nodes are joined together and they know the next one, right? So it's easy for you to search through, it's easy for you to like peruse through them or pick through to know what the first value is, which is the head, and what the last value is, which is what the tail. So this is the basic first basic construction of what. So how do we call the toString method here? So we can call the toString method by now saying that what node dot what toString, node dot toString, and you call something like this. Now when you call this is supposed to print out what? It's supposed to print out what? Because the idea of this node here is it's only printing what? Value. And that's what whenever you call it toString on what, when you call it toString on the node, it will only print what the current value right there. So because if you look at it here, we're saying like if there's a callback, use the callback to on value, on this dot value, that is this current node here, what is value. And if we look at this current node, the value is just 1, and that's why when it does everything it's supposed to do, it only gives us what, only give us what 1 right here, which is what here, and it's the string. That's why it is quoted. Now the next thing here is to let's create what the linked list itself, right? Which is something that will now have what a head, and something that will now have what it like some of the basic methods that we expect the constructor function to have. So again, I'm going to just run this with functions basically, but just understand that we can also do all of these with what, we can do all of these with classes, right? And TreckLab in that JavaScript algorithm did this whole thing with classes. So I just choose to use functions here. So the first thing here is to we need something to we need a way to know like, okay, what will be the current head. So if they created the linked list and they also specify the head, then we want to say what the head is what null, or we also need what, we need tail, right? Which is, I can just duplicate this and then we have what tail right here. So and what else? So now how do we create, like, how do we, what are the things that we want our linked list to be able to do, right? We want to have a method to maybe right, to append, right, add a new node, which is append, right? To do append here, we want to say append is a function, it accepts a value, right? And what does this do for us? So the thing here is that we will first turn the value into a node, which is what const this. And the next thing is to if there is no head before, make the new node the head. And this is very, very direct. So if this, right, this dot head, right, not head, right, so make this current node now, that is the node that we just created. So we'll say like this dot head equals to what, equals to new node. And we also want, because definitely if it is one thing, one value, it will also be the only thing that will be the head, and it will also be the thing that will be the tail. And then we have the ability to what, to return this. And all right, so if now, if there is a head before, right, and you're trying to add something, right, so what should happen now? What should happen is that what, otherwise now add what, the new node to the what, to the tail, that is the end of what, end of the what, of the linked what, the linked list. And so automatically we would have something that says that what, this dot tail dot next equals to new node, right? This dot tail this dot tail dot next equals to new node, that is, yeah, so that if there is a head before, right, it means that there'll also be a tail, right, literally. So we now want to say what the next thing, right, which is what is going to be the new node that is created. And you also want to say that you also want to set this dot what tail to be what to be new node. I'm trying to understand what is happening here. Otherwise, append the node to the tail, right? Append the node to the tail. Append the new node to the tail. That is the end of the linked list. Maybe let me just run this by code and then I'll see what this gives me. So basically, if I create a new linked list by say const what LL equals to what new linked list. So new linked list here means that yeah, it's just plain object, and I should just have something that is plain, and it should be LL should be just plain, right? So I want to do append, and I want to append 10. And if I append 10 now, I should have an object that has what? An object that has both 10 in the head, and in the tail there'll be 10, and the next is going to be pointing to what? To null. So if I also want to append one more thing, and I say append 20 into this now, what do I have? So I'm supposed to have something that looks like this. Like the current head is going to be what? The current head would have the value of what? 10, right? And the next node now will be what? 20, which is the second thing that we are appending, right? And the next of that 20 will be null because there is nothing there. And automatically, right, the tail is going to be 20 because tail is the last thing there. So that is the process of what? Just creating an append function, right, for what? Linked list. Again, to just see what's going on here. If there is no head before, we just make whatever node that we are creating, we're making it the head and the tail, right? And if there is a head before, right, we want to make sure that we are setting the what? We're setting the tail dot next to be that what new thing, and we're also setting it to be the tail because it is definitely the last thing, and the last thing is supposed to be the tail, and it's supposed to be the next for the head, right? So the next for the head is the tail. So that's the reason why we have what these two things here. Now it can be first pretty confusing initially, but the reason why we have this is because now when the head is currently existing, the head here is 10 before, and I'm bringing 20. So automatically, right, 20 is going to be the next, right, for the head. And that's why when I hover on this, you would see that what for the current head is 10, but the next for that head will be 20. But this 20 is the last thing, right? So it automatically means it will be the last thing inside of what? Our linked list, and automatically it will be what? The tail right there. So that is the beautiful thing about again, the order of setting this is very important because you can't set this first. You need to first set the tail right next to be what? The new node, and then you now go and change tail itself and set it to 10 because the tail automatically must always be what? The last thing in the linked list. Now if I had 30, what happens if I had another one here where we have append 30? So what happened? Automatically now we have what? Head is going to be what? Head is going to be 10, right? And the next will be 20. Now inside of this 20, now the next will be what? 20, and inside of this 20, the next again will now be 30, and the tail must be 30, right? The tail must be 30, and that is like the basic operation that happens during the append phase for a linked list. And so somebody can ask you to prepend. That is, prepend means you want something to come and become the head, right? You want to force something to come and become the head. So you want to do what? Linked list dot prototype dot prepend, and we want to say that okay, Copilot already wrote this for us. So we're saying that this is the new thing that is coming, right? And this dot head. That is, you know that whenever we are creating node takes two things. Node takes value and it takes what next. So automatically when we bring in a new value, we say the new thing will be the value, and whatever the former head was will now be what the next, right? And we're saying that what set the head, since the head is now empty now, we're not going to say, oh, set the head to be what the new node. Now if there is no tail, right, make sure that what the new node also is what the last thing, right? If there is no tail, otherwise return everything. So here let's try to make 100 the what the head, right? So here we want to say hell dot what prepend, right? That is, I want to make 100, right, the what I want to make 100 the new head. Automatically if I make 100 the new head, right, what should happen automatically? Now let's view what we have, right? 100 becomes the head, and whatever we had as head before will become the next, and automatically they will be followed by what 20 and be followed by 30, and by default now 30 will still remain what our tail. So prepend is another beautiful thing, and the interesting thing with all of this is that what you can chain them, because eventually we are returning these, right? So we can chain the operation, right, because we are returning what these. I hope this is literally like clear. Again, it's just what we are using functions here in the TrackLab algorithm repository. He used classes, but they're basically the same, the same thing right there. What other thing can we create? What other thing can we create? What other thing can we create? So let's say append. We can also now insert. So how will insert work? Insert is going to be a little bit complex. I'm just going to copy his own insert and bring it in here and see if I can. But let's try to see what are the other ones we can find. We can delete the tail, we can delete the head. I think those ones might be easy for us to implement. Delete the tail and delete the head. Because insert and delete, insert, they're going to be a little bit complex, but we should be able to like find a way to write it. So if we say delete head, delete tail, so what will be the flow to delete tail? And another thing is here for all these things here, I think we can do dot to string, and this is the beautiful thing here, right? We can do a dot to string. I think, is it dot to string? Node should have a dot to string. Yeah, it should have a dot to string. It shouldn't be object. It should give us something. Let's see. Word. Another thing is that if LL is a linked list and it contains node, I feel like it's likely that this dot to string is not working, because if this dot to string were to be working, it has to give us the value, right? The string of the value. It has to give us in here. Except if it is not working. Except if it's not working. All right. Because what is this linked list now? What is this ll.value? ll.value, right? The value should be what? It's saying that here ll does not have ll.head. Okay, so we want to say ll.head, right? And then we want to see dot the string of that, and which is supposed to give us, like, I think it should be 100 now, right? Which is this. What other thing should we start supposed to give us there? And I think eventually we can also implement the toString on the linked list, right? Which can also implement it to string on the linked list, right? Which is going to be a way to print out all the things inside of what the linked list. I think let's just do that first so that it will be very easy for us to print, right? To string, to print everything. So we want to do linked list dot to we want it to have. So we're going to loop through everything, right? We're going to look through everything. Okay, so it means that this is what TrekLab did in his own here. It means he wrote another thing called toArray, right? He wrote something that is called toArray. So probably if we want to follow that, we can try to implement that. But let's before we do that, let's try to see if we can also do something to array, right? Which can look through everything for us. And so what will this do to array? And to array means that it's going to basically loop through each of the linked list, each of the things inside of the linked list. So while there is it's going to be something like while there is maybe something like while there is add.next, right? We want to keep looping through while there is so okay, let's see. The condition here would be what we want to check is we want to check, this is definitely returning what TrekLab has. So but let's see, while while there is what this dot head, that is, it means that anytime we have a head, while there is head, right, you want to push, right? You want to do array dot push, right? Whatever that value of that head is, right? You want to push that thing. Is it the value that we want to push now, or we want to push, is it the head? Let's see what's inside the head, because the head is supposed to contain, let's push this dot head into that array. And now to keep the loop going, right, we're trying to keep the loop going, and so we want it to now move and change the value of this dot head to be equals to what the next thing, all right? That is, this dot head will now be equals to this dot head dot next. And this way, right, let's see, let arr equals to empty array. So here, if we kind of like try to run this thing now, the goal there is to return the arr, right? So if we want to run this now, we want to do console.log this dot array. Let's see if this is going to work. Not sure. Right, so this has to be this dot value, right? Always put the dot value in there, and you can see, right, automatically I have what 10, right, 100, 10, 20, and what 30, right, which is what we did. That is what we want to push into the ARR is what the value, not the is the value, right? That's the value that we are dealing with. And also the reverse of this would have been what the reverse of this would have been is what? what the reverse of this would have been. The reverse of this would have been the reverse of this would have been something I can do, like a, maybe it will take arrays, right? Take the arrays, take array, and what, return, take the array and turn it into a linked list. So we want to do something which is what, linked list dot what, linked list dot right. Let's see. So what is this? This is anytime we have a new set of value, which is an array of things, I return the linked list. So let's see here. Let's save this into array of LL equals to this, array of LL equals to this, and we then want to console.log this. I want to do how do we call this dot from array now? From array. Because it's the static method, so it has to be like linked list dot from array, right? And you want to pass it array of ALL, and yeah, it's supposed to return something. It's supposed to write new LL equals to this, and we should be able to console.log this here, and this should give us the linked list back. The head, the value of the head will be 100. The value of the next after is 10, the next after that is 20, and the next after that is 30, and 30 should be the tail right there. I mean, this is very beautiful, right? You see how beautiful it is. So let's try to do like a delete head. But what happens when we delete the head? So if we delete the head, I think the next should become the head, right? If we delete the head, then the next should become the head. If we delete the head, the next should become the head. So this way, if we delete the head, right? If we delete head, then we make the next the head. So we want to do linked list prototype. Let's see, using Copilot. So if there is no head, you return null because there's nothing to delete. Then the head that we want to delete is this head, and if this head has a next, then you set this dot head to be what that next thing helps, right? If there is, right, you set the head and tail to be null, and I think like this works. So let's see here. So if I try to delete the head, which is 100 now, that is LL, let's just do LL dot what, delete head. My 100 should be gone automatically. Beautiful, right? Our 100 is gone automatically. And if we call the head one more time, it takes the next one, and it keeps taking until the result is null, right? LL will be null here, LL must be null here, right? And then must be null there. So that is the way it works. So I mean, this is beautiful, right? It's beautiful. And so let's also see if you want to delete tail, to write something that can implement delete the tail. So to delete the tail, so how will delete tail work? If we delete the tail, if there is no head, reduce this, then delete tail. Okay, it's almost the same thing, just to make sure that this dot tail is equals to the deleted tail. And if this dot head, is equals to tail, right, automatically it means that we only have one thing inside our array. Anytime our head is the same thing as the tail, it means we have only one thing. So it means that it will automatically return the deleted tail, right? And otherwise, now we want to set what? If there is another head in the picture, right, it means that we want to set the current node now, which is going to be what? This dot head. And like automatically when you delete the tail, right, when you delete the tail, you want the next the last next, that the last next, you want it to become detailed, and you want to readjust it like that. So that's what this while loop is doing. That is, while there is what? There is current node dot next, right? You then want to, if not current, if not current node dot next, then you want to set current node dot next equals to null, right? Such that, I mean, the idea of this one here is to set the current node, like the, so the, what would now be the current node now, you want to set its next to be null, because automatically we've deleted what the tail is. So it means that head should not have, like, if there's only just, if there's just two things before and you take the tail out, right, automatically there should just be head and not null should be the next thing. Otherwise, readjust, right, make what the current node the current dot next. And because this is a loop, right, this is just to keep, so if we have four things, let's try to play with it so that you kind of like understand what's going on there. So if we try to play with it here, right, so let me comment this out and bring back my 100. Now, if we want to delete tail, right, if you want to delete this tail, which is 30 here, now what you want to do is you want to automatically 20 becomes the new tail, right, and 100 is still the head, but there must be what, this one must point to null. Now, instead of, before it was pointing to this 30, so it must now point to what? Null. And that is what is happening there. That, okay, let's say ll dot delete what? Delete tail, right? You can see it has deleted the tail, but automatically, if I see what, if we check what ll is now, you would see that what, the head and tail is now what? 120, and in between the head now, right, if we look at the head very well, because you would see that the head will now be what? It's going to be something like, the head will be something like what? 100, 10, and the next of the head is what? 10, and the next of that 10 is what? 20, and the next of 20 must now be null, which is what we did here with this delete tail, right? This while operation tries to like bring everything closer back to each other. That is, since one member has been out, then how do we just bring everything closer back? And that's what that did there, right? All right. So let's try to delete other ones. Let's see if it works the way it should work. So here, if we also try to delete more stuff, you see it has gone. Delete another thing there, and now the head will only be what? Will be 100, and the tail will also be 100. And that's the beauty of this here, because if we ask for this is, but the tail must also be 100, right? The tail must also be 100, and that's, you can see now that it's now calling this, it's now calling, it wasn't just only this region before, it's now this line is, okay, it's calling this line. And if we delete the last one, I feel like if we delete one more thing, right, it will automatically what? Now enter into this if statement where it will set everything to be null. But I think the goal there is that anytime we're deleting, it is returning the value that was deleted. Anytime we're what? Deleting, it's deleting the value that was deleted, right there. So that is another very cool thing to know about linked list. We've been able to delete the head. You've been able to delete the tail. What other thing do we want to implement that we've not implemented? So the ability to insert. I don't think I have an idea what happens during inserting. I don't have an idea of what happened during inserting. Let me see what tricklet implemented here. Okay. I mean, let's see. I don't know. I don't think I have an idea, but I know that, well, I think I know what's going on inside insert, because you want to come and insert a particular thing. Where are you inserting something? So you will be specifying the index, right? Prototype of where you are, what the index will be, what where you want to insert, where you want to insert something. So that's why here it is accepting what the value and index, right? The location, right, of what we want to do right there. So this is insert, and I think here we will be doing would have actually do like a find, if we had something like a find implemented to find that index. And when we find that index, how do we implement this insert? Let me see. So here, so insert actually is like, if the index is less than zero, automatically set it towards 0. So that's a check, right? Which is if index is 0, if index is less than 0, if index is less than 0, return, you can return null. If index is less than 0, what it did here is what it was returning 0, right? It was returning 0, and yeah, use the index. So that's the first thing. Then if the index is equals to 0 in itself, right, we want to prepend. That's true. If index is equals to what? 0, prepend. That is, if index is equals to 0, prepend, we call prepend. That is, this will bring the head to carry out the first thing. Now this is the tricky part. Was saying that whatever the value is, let's convert it into a new node, right, to be inserted, right? And we want to get what the current head is, right? Because we wanted to get the current head and we want to get a count, right? Let's see. I'm just copying what this guy implemented because I don't have an idea of what's going on. So we then want to do a while loop, right? And the condition there is what? Look at the condition here now. While there is a current node, I mean, if there is head, and current index is less than index minus 1. Why are we doing index minus 1? I'm not sure. I know what's going on here. Copilot, thank you. Let's do while there is current node, that is if there is head. We want to now create so if count, if the current index now, let's do this. If we set this to 1, what will happen? Let's see. If the current index is equals to 1, the current index is equals to the index. We want to, if the current index is equals to the index that is specified. Okay. If the current index is equals to the index that is specified that they want to insert, right, then what you want to do is what you want to set what the new node dot next. That is set the whole new node now. That is, what is the new node now? The new node dot next. That is the next of the old thing, right? You want to set it to be what? To be current node dot next. And then you want to now set what? Current node dot next. I don't think I understand what is going on there. We want to set I'm not sure, kind of like pick what is going on here. I know it's going to be a little bit tough to implement. If current node is equals to index, let's do this instead of making it current node. Let's do something like this. I don't know. Well, let's see. Let me just copy what they have. I'm going to test run it. Then set current node equals to current node dot next. And you want to increment the current index. And if current node right, you want to now do new node dot next equals to what? Current node dot next, and you want to do current node dot next equals to this, and else we want to then do another if statement by setting if this dot tail is this, that is, if this dot tail is present, we want to handle the tail, else you want to handle the head. So you want to set this, and we want to set this dot tail next because new node, and set this. I'm sure I don't understand why we are breaking here, and I don't understand what is going on with this increment here. So let me try to figure it out, what is going on with what insert. So in the current thing that I have was what we have. We still have the 100, 10, 20, right? So if I do a ll dot insert 15 to be 1, now automatically that should displace the head. It should displace the head if our implementation is correct. Does it mean that does it not mean it has to be 0 if we want it to be the first thing? Okay, it has to be 0 for it to be the first thing. Now, what is the operation that is going on here? That is if index is equals to 0. Okay, if index is equals to 0, okay, prepend, that works. So if we make it 1, now what happens? We're saying that create a new node from that 15, and now set the current node to be what the head is, And what was the head before us at this point? The head is 100 and every other thing that remains. So they will be what? The current what node. Then you want to get the current index. Then you want to now do this while. So if current index is equal to the index break, and so when it breaks, it doesn't use this loop. It comes in here. If there is current node, then you want to set the new node, the next for the new node, right? Yes, because the new node is 15. No. Okay, yeah, the new node is 15, and so you want to set the next of that what? The next of the new node to be what? What our current node is. What is the current node? Current node is the whole thing, but is the next of it that we are taking now. So it means that we're taking 10 upward, right? 10 downward, right? 10, from 10 to the last 10, which is 30. We're making it the next, right? So, and then we're now reinserting next. Okay, we're now reinserting next into the head, right? We're now inserting the what? The next, which is this new node, into what? Right. So that's what this current will be 100, and by the time we insert what? By the time we say the next of this to be what? 15 and the rest. This makes sense. I think I dig what is going on here now. So this way it does make sense. Okay, what if we say this should work for insert 15 on what? On 2. I think I dig what is going on. It's always follow this place here. It's always use this place, this approach. This will only be considered when this will only be considered when whatever we're trying to let me see what will cause this to be the value. What will cause this to be the value? Insert 15 into 3. So what if I want it to be 4? That is, I want this to be on 4. So definitely 15 should be the last thing. But how does this work? How does this work? So the way it will work is that, yeah, is this else line is creating 15 and it's now setting the current what? The current node is what? This dot head, right? And right. So while current node, that is while current node, then we want to do we're not breaking this, right? Because current index is not equal to the index, no, right? What we want to do is we want to do current index now. Set current index. Set current node. The current node is head, and attach set current node to be equals to what? Current node is now equals to current node will now be equals to current node dot next. So here, what is current? Current is 100 and every, like the whole head, right? But now that there is head, you want to now say what? All the next of what? All the next of the current of the head, that is from 10 downward, you want to put them inside, make them the current node. Okay, so by the end of this operation now, current node will just contain what? 10, 20, 30, and that's all. Okay, and then we now increase what? Increase this one to 2. Then we then go again, right? While there is this, obviously there is okay. So by the second operation, right? Okay, it will keep in, like, now it was this value of the node was it was 10, it will go to 20, I think. It was 10, it will go to, it was 100, it will go to 10, and then it will go to 20, and it will go to 30 the last. So what this loop does is, like, this loop is a way to keep looping through the linked list until we get to the exact one that match this condition, until we get to the exact one that matches this break condition. And it is because it is this break condition that is key, because it's until it is true, which is what? Until the current index is now 4, right? Current index must become 4, which must equal to 4, then it must break. And once it breaks, it comes in here. And the moment it comes in here, now, what is the value of what? Our current index, our current node. Our current node is what? 30. So automatically, it will set what? The next of what? It will set the next of our 15, because this is 15. Now, the next of 15 is setting it to be 30. The next, is it? This is here. Here is 30, and the next is null. So we're setting, we're setting this null, right? This next here, we're setting it to be the what? The last thing. So it will be now, new node will be what? 15 and null, right? And then we want to put this whole what? This whole 15 in current node, right? That is this whole thing, which is this whole thing, let's see. So we want to say current node is 30, right? And you want the next of 30 to now be what? 15, right? So at the end of this operation here, current node should have 30 and 15. That's what I think it must have. 30 and 15, right? 30 and 15. And so it will be 30, it will be 30, it will be 30, and the next will be 15. It's supposed to return something here. I get 30 and 15, how it is working, but that's not what we expect to have, because what would be this dot head? That's what I need to know. I need to know what will be inside this dot head. So this will now be 100, 10, 20, 30. Okay. Ah, I see. Ah, damn. That's a very, very interesting way to think. So because 15 is just going to the last, is going to a particular index. So the one that is Whatever is on that place is the only thing that you need to really deal with. And which was what? We needed to remove 30 and replace it with 15. And that's the only major thing. Because automatically, if we replace what? If we replace 30 with 15, replace 30 with 15, and is it replace 30 with 15? Or we just want 15 to become the next of what? To become the next of 30. I still need to really understand what is going on behind the scene, but it's very, very tricky and interesting. That is very, very interesting because I need to really try different examples of this. So if I'm dealing with three now, I don't have business with what? I don't have business with I don't have business with it was 30 that was here before. Was 30 that was here before. And yeah, I just need to know. It is 20 now that I'm going to find. I'm going to cut at 20. And but I need to. So I would need to add 30 to 15. And once I had 30 to 15, right? Once I had 30 to 15, that is 30 automatically be the next for 15. And since we have 15 and 30, we just need to join 15 and 30 to what? So automatically, if what we are looking for to is what? If we say this is if we say this is I think I get what's going on. So if we say this is 4 here, so what will happen is it will run and try to cut. It will try to no, that's not what I want to do. So if I say this is 2, right, it will rush and cut. It will rush and it will just automatically put 30 and 20 because that's the only time where this if statement is going to be what? This if statement is going to break here. This if statement is going to break. That is this time when this if statement is going to break out, right? So I just cut that time when it's going to break out and append those value to what the current word. Append those things. Oh, damn. Append those things here. And so here I'm now going to have, yes, I'm going to have 10, 15, and what? 10, 15, right? Because position 10 is what? 10 is what we want to lead the charge now. So I'm just going to add, the first thing is I'll first add 20 and 30 to what? 15. Add 20 and 30 to 15. Add 20 and 30 to 15. Then automatically join that 15 to what? To the last one, and it fills the whole linked list back. What? That is very, very interesting. There's a lot of code here, right? A lot of code here. Still need to play with it over and over so that I kind of like get but I have an idea of what the whole thing is going. And I think the last thing we should try to implement is what? Implement is linked list dot delete. So I think it's also going to take something similar to what we have with insert because we need the index. So if the index is what? 0, right, we are deleting the head. If the index is 0, we're deleting the head. If index is 0, we're deleting the head, right? And if it is something else, I mean, it's just going to be like, if it is something else, I think it should be just the same way. So instead of adding here, instead of adding in this if statement here, we're just going to instead of adding this new node and setting a next, we're just going to delete. Since there's no new node, right, you delete whatever current.next is, because that's the particular dot value of that thing. That's the particular one that we want to delete. We get rid of it, and then we would then join everything back together. Right. So how does that work? Yeah, there's a lot on the screen, so let me just try to minimize everything. We started by creating nodes, right? And we created toString for node. Then we started with linked list, right? We created the append, we created prepend, then we did some operations, then we created insert, which is like one of the toughest one among all of them. We're trying to implement a delete. Then the deleteHead and the deleteTail, I mean, they are quite very beautiful. Then toArray and fromArray, right, helps us to convert the whole linked list to an array, and then also help us to take an array and convert it to a linked list. And so for the delete operation, deleted node is going to be null. I need a way to delete this whole thing. The current node. The current node, and then we want to do this, right? And then we want to do a if current node, right? Then deleted node is equals to current node, and there should be a else, right? And return null. I think we can then return this. Hopefully, let's try to try run this. So what is the current LL that we have? What's the current LL that we have? How do I know? Just do toArray, right? Let's just say, let's just cut this whole thing. Let's cut this whole thing there. That's the LL.array. LL.array here. Here. So, and after this LL here, before this LL.array, let's try to delete one. LL.delete, and we want to delete the first one. If we delete, let's see again. Okay, so yeah. I think it works, because if we delete the first one, that will be the head, right? We delete the second one, it will delete the third one, 15, it will delete, and it will delete the last one. We should get length. We should write the length. Find a way to find the length though of a linked list. Implement something to calculate the length of the linked list. But I mean, that's the whole I mean let's look at the delete again. I mean, it was like, I knew it was going to be like just the same way with what, with the insert there, right? If it is the first one, you are deleting the head, and if it's the last one, I bet we should also have another condition here. Let's think. So here we're saying get the head and get set a current index. So while there is this dot head, when there are other things, right, we want to keep looping through until we break, right? We need a particular situation to break, and it's that situation that we are breaking that will now tell us, okay, the portion that we want to delete. So if there is current node, right, this current node will now, it will tell us like, this is, you see, this is what, 20, this is 20, 30, 20, 30. So we'll join this 20, 30 to because again, what is the command? What are we deleting? We're deleting the fourth one, right? What's the fourth one? The fourth one is starting, right? So we need is the fourth one that we're trying to delete, which is the 30, right? So the delete node the deleted node that we need to delete is what? The next one, which is this 30 here. Right, we get that, and then we then say the current node dot next equals to what? Would then be what? The current node dot next, which is what? Null, right? And what will be this one? So this will now be what? 20 and 30. Let's see. So current node. The current node will now be what? Current node will be what? Current node will be what? 20. But I think if we have deleted 30 here, I'm not supposed to go back to 30. Let's see what we have for this here. Let's see. This dot head. Seems as if this is not reachable. We need to find a way to but I think this is just basic operation. I think like other interesting thing that we could do is what we could find a way to work with length, find the length of a linked list. Okay, I think something was also writing something for us, which is just like we're counting, we're trying to count through. It's a function, but we can make it a property. We can make it a property. Doesn't have to be a function. We can make it a property. What else? What else can we do? I mean, those are like basic operations that we can do here. However, even me, I need to study the deleting and the inserting again. Those are the two major complex things in this linked list. But outside of that, everything works. Everything works perfectly fine. And yeah.